Well, hello everyone. Here we're gonna be uh having our learning hours. Gonna That's a cool instructor. I'm gonna write that on the board. Learning hours. Not good. Okay, so today we're gonna be working on let me show my screen really quick. On basically reviewing homework 5. So we're gonna go to part A and then going to 1 and 2. And possibly after that, I'm gonna review some concepts from the class that we had today. And yeah, you can call it a day. So let me stop sharing. Good. So okay. So let's define. Okay, what do I do now? What's the process? I want you to guide me. Huh? So let's say that we have this lecture. So I have that back. We are looking for. So you said you want to calculate the average velocity. Okay. So let's do it. No, okay, let's go to the second one and then we can go to the first one. All right. So we're calculating acceleration. What's the formula for acceleration? So the formula for acceleration. So right. All right. What is it? That's better. Good. All right. Let's tackle one at a time. So let's do see, let's say that this is for turn A plus, and this is turn B. This is turn B phase, right? So we have D, E, right? So yeah, if I get the derivative for some kind of this lecture, what do I get? Okay, let's go back a little bit. So, okay. But let's go with B first. It's the same thing, because I like to go like relatively easy to then a little bit more complex. So if I want to take the derivative of this vector, what do I do? It's okay if we do it. It's all right. Okay. So basically, when you are taking the derivative of vector, in this case, as we did, for example, in class today, with pressure, what you're doing is, if you're doing it this way, you're basically taking the derivative of everything with respect to x. So in this case, you have of course, we have an actual derivative. And basically, what you gotta do is take the derivative with respect to t for each of the components. No vector velocity. No velocity vector. 0, 1. Right. So basically we treat each of these as one. Correct. So what will be the result? So, huh? I'm not saying that it is zero. I'm not saying that it's not zero. I want you to think and let's do like argue why it is or why it isn't. Huh? Right. Because there's no change with respect to. Right. So what will we get? 0. You get the vectors there. Good. I just want you to be confident because it's really in this type of exercise. It's really easy to not be sure about exactly what you're doing, and then you like kind of right. Yeah, you just take the derivative with the time, and this could be any variable. We can change this equation and say, I don't know, I'm gonna define this formula phi, which is the divergence of the vector b cross product with the acceleration vector, and then like that could be something that you could get in the test. Hopefully not, but and you gotta basically know what to do and how to operate in different uh having like different operations, like the one that we went over, like the cross product, dot product, and basically those. All right. So we already have that. So this section is 0. All right. So let's go to B to A. Okay. So we have so this over here. This is a question that I had before. That's not a dot product. That's a multiplication. So multiplication. And the reason is because we're talking in a vector, right? And we're getting the vector 0 here, right? If you get a scalar, you're just adding that scalar to the vector 0, and that doesn't really make sense, right? So we're multiplying. So we're basically multiplying this vector, the velocity vector, with the gradient of that vector, right? Awesome. So you want to calculate first the gradient and then we multiply it to the vector? Let's go for it. So let's see. Okay. Do you know what a gradient is? Yes. Yes. C. All right. Good. Good. I get those mixed up. So let's say I'm happy that you went for it, right? So huh? Yeah, that's 4. So you're right. So we get 8x. Excellent. Across. So here. Okay. Y. What are you doing in this location? I'm not saying that it's not. I'm just asking you to tell me. Uh-huh. Yes, you're doing it wrong. But let's put a pause. Right? Okay, let's define vector. Tell me a letter. A. Beautiful vector A, right? So vector A is equal to A1, A2, and A3, right? That's boy A, right? If you want to get the gradient of boy A, what you do is that you get partial of A with respect to X. Basically, or in other words, you get A1 with respect to X. Then, next row, you get partial derivative of A2 with respect to X. Next row, partial of third component with respect to X. And then you do the same for A1, but with respect to Y, A2 with respect to Y, and A3 with respect to Y, and then you do the same but with respect to Z. So the first component with respect to Z, second component with respect to C, and third component with respect to Z. Hello, Kristen. All right. Oh, my bad. My bad. My bad. Where? Rock. Guide me. I go wherever you want me to go. I'll go. First, we're in row 1, 2, and 3. Yeah, column 1. Why? So this this one is the one that we are. The second component. And if you have the solution ask. Right. That's good. Oh, we do that. We think that, yeah, we think that basically this one with the lyric of this, the 50 water table, you're right. Yeah, so this. Correct. Exactly right. And then what? All right. You have to repeat it. Oh. Sorry. My bad. So yes, we got the gradient. And then if we continue here, we have A of the vector velocity times the gradient of the vector velocity. Let me erase this really quick. So I'm gonna write the vector and I want you to multiply it, all right? So vector B is, we said, 1x squared, 1/2 y, pi b, which is multiplied by a x 0, 0, 1/2 pi 0, 0, 0. All right. This is A. Do you know how to Yes, yes, yes. And what will be the result? Yes, yes. Okay. Oh, oh. So if you multiply this, as you said, you get this vector, and then you rotate it, and then you get this times this, plus this times this, plus this and this. And that, whatever you get, is your first element here. The thing is that if you have a little series, we only care about this guy. But yes. All right. So we'll do the answer there. Yes. 32 x cubed. All right. What else? Yep. 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 Pi squared c. Yes. Okay. That's good. I mean, that's what practice is all about. At the beginning, you and I didn't know what the hell I was doing, but after reading a little bit and doing more practice, you get confident. If we're coming this way, yeah, yeah. Right. So let's do for one. Just for practice. Oh, there it is. So same vector, right? Oh, unless Kristen, well, I don't know what she left. Let's do for one, and then if she has a question, like she can let me know. Oh, thank you for coming. I forgot to tell you. So what's one? Average velocity. What is it? One over area. Uh-huh. Uh-huh. Sweet. Okay. Yeah, that's exactly how you do it. Mm-hmm. Wanna do it? I mean, we can find our boundaries to be the Wanna do 1-1? That's, yeah, it's not the answer of that. This is not a unit vector. The magnitude of this is the square root of 1 squared plus 1 squared plus 0 squared, which is not equal to 1. Oh, okay. So let's do that works. There you go. Do you have any questions? No? Okay. This is what it's gonna give you that that you know that pumped for homework 2 now. Oh, yeah. We only have homework 1. Thank you. You wanna down? Yeah. It's just really, yeah, really stuck in there. Yeah. You sure you can break it by parts? That's what you should do. Like I first calculate the area. Once I get the area. Mm. Yeah, that's the reason I did it like that. So I was like, I don't know. Uh-uh. Be careful. You're not wrong, but kind of. Yeah. You can calculate 1 over area and do whatever 1 over what you said. Mhm. Yeah, yeah, for sure. Beautiful. Yeah, this part is done. So what the next thing that I usually do instead I go for the A. What is the A? When you do it that part, like you saw, like breaking it down like that, it's really hard to, or it's harder to mess it up. Yeah, yeah. You can say the I is equal to. Oh, you can go for it. No, whichever way you feel more comfortable. But yeah, yep. Thank you for coming. Yeah, I went to get her closet and I was expecting to be that full, so I couldn't. Yeah, I wasn't able to come earlier. It worked out. Worked out. Worked out for. Are you in Qantas? All right. Yeah. Yesterday we had a homework. It was very interesting. Okay. Yeah. Yes. Mhm. Oh yeah, for sure. Yeah. Yeah. 1/2, 2 to 3, 1 to 3. Yes. Mhm. Yep. 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 Mhm. Okay. Mhm. Yeah, it's slightly more annoying. That's good. It's I'm pretty sure you're gonna get a problem that is slightly more annoying than what you get in your Congo. Or you're gonna get less of it. Oh wow. Yeah. You didn't get that messy. Yeah. And you already have this right? Yeah, but if you don't. No, if you take it out, you well say that you cancel with this one. Yeah, yeah. So, huh? Oh yeah, I did. Yeah, yeah. I'm not. The rules say that I cannot give you answers. So it doesn't say anything about me creating a problem, but it's kind of similar in helping you solve it. And also, I create like a slightly more difficult problem, so good practice. See, so you're on expected Z. You get that. Yes. C. Yes. So, yeah. Yeah. You guys are gonna do so well on this test. My goodness. Gonna be trying to or gonna be competing with you guys to be in LA next semester. Oh no. Where? Oh, this one? Yeah, 4x squared, 1/2 y, pi z. That's the VAG. So just start using like just constants like E, golden ratio, pi. That would be the answer. Yes. That will be the answer for average velocity. That will be the average velocity. Pretty quick. Okay. Out of 10. Great job. All right. Let's see what I can. Oh, oh. Was thinking about this morning. So let's review what we did this morning. So you guys, you were late. Awesome. Okay. Okay. Good. Okay. Let's go there. That's an amazing opportunity to. Okay. So basically, we're talking about we were working on large volumes, specifically for and static space or a scenario. So we define our coordinate system, which is x, z, y, and then we define what's a it's a large volume. All right. And basically what we are having is multiple pressures. We see what we're trying to do is to start like learning about how to identify different forces acting on a volume. So for example, here, what plane is this? So usually the way that I look at this is when you're in a 3D plane like this one, you get a plane where you get a, a fixed value of one of this constant. You can look at it this way. For example, if you get the yes, so it's yes, correct. My goodness. My goodness. Yeah. So it's good. It's good. I'm glad. So this is the force P, which is the pressure, and is what do I call this? Restricted to the X plane. All right. Then what about this plane? Y plane. Yes. I want to. What about this plane? Steven. Oh, what is that? Sir, because this distance is delta x. So yes, delta p restricted to x plus delta x. All right. Okay. Then we went over the force of gravity. So the force of gravity is defined as the integral of the volume times rho, which is the density, times the gravity vector v. The thing is that since in this class we're working with a cube and it's a large cube, we can define the volume this way. So vector force of gravity is equal to x1, x2, y1, y2, c1, c2, rho, vector g, dx, dy, dc. All right? But we already know the value of this integral. And we know that since it's a symmetric volume, like each of the different planes of sides of the volume do not depend on their variables. So we can describe them as we said it here, delta x, delta z, this one, b, y. So the force of gravity then will be delta x times delta y times delta z multiplied by rho and the vector. Okay. And we can define the magnitude of g as g. So if we want to write g as a vector, we write it this way. That's very important because depending on how our coordinate system is set up, we have to take into consideration that gravity is negative. That's something, for example, that I asked during class 9. All right. And then if you want to write the velocity, I mean the force of gravity as a vector, it suffices to use this same logic, which is having first component equal to 0 and second component equal to all of this. Y, C, rho, G. So this has a mistake. What is it? Yes, it's missing a negative. Nice. Very important. Because then you add weird stuff and yeah, we don't have, all of a sudden we don't have a static problem anymore. It's moving and it shouldn't be moving. So yeah, it's good. Basically, in this part, I still have struggle like understanding, but it's okay. Basically, we are defining then the surface forces, which are the integral of the surface with the normal vector. This is called a tensor. No, it's not a tensor. What's this again? No, I think that was this. This is yeah. So this tangential forces and pressure forces. It encompasses both because yeah, it's coming to me. So this guy, it's like a matrix in which you have your how do you call it, your volume, and depending on what entry it is, it's telling you a different story, let's say. So if you get x, x, y, y, and c, c, this type of pressure is, I don't want to say incorrectly, but it will be pressure. You can correct me on that. He said that last class. Okay? And we were talking about super forces. Yeah, these are normal forces. Normal forces mean, which is, this is the symbol for orthogonal forces is the same or equivalent to pressure, right? It's like a fancy way of saying the same thing. But then if you have sigma x y, then this is a different, because we are in the x plane, we're looking towards y. So, for example, this guy over here is a shear force or a tangential force. So, when we go to our beautiful cube, we are in the x plane. What is the x plane? But now it's pointing to the y. So it's shearing. So this force will be like here, this plane, but pointing up. So this will be sigma x y. But for example, this pressure over here, it's in the x plane, even though it's like coming from the other side, but it's encompassed in sigma x x, because it's a normal, right? We know if we could, get asked something like that, but that's basically what it means. Will be something like, will be nasty, but it will be something like, given the matrix of surface forces, define what each of the entries are or what they encompass. So it will be okay. So for example, sigma xx in this scenario only has that force. Oh no, and also has that force. So it will be sigma xx or the pressure or the normal forces, and sigma xx are the pressure in the x plus delta x plane plus the pressure in the x plane. I didn't get a question on that. That's fine. Just, I don't know, sharing thoughts. All right. So let's do two more and then we can continue with this, because it's also kind of important, but I was trying to think my way through on what this was, and I got, I think. Matrix. So for example, when you have this, I think it's only two lines, not three. Yes, it's two. You are saying you have the entry matrix, which is 3 by 3. If you had, for example, this means that the entry matrix, the 4 or 4 by 4. And when you, then that, just to reiterate, the identity matrix is a matrix which one of its diagonals, it's 1, and the rest are 0. So if you multiply another matrix by this, or a vector by this, you're gonna get the same vector back. That's the reason it's called a density metric. So the density in the sum, when you're summing something, the density of summing is 0. When you're multiplying, the density will be 1. When you're multiplying a matrix, this is a density, right? Good question. Good question. Okay, let's. So one. Okay, I'm gonna ask one of two different questions to each of you. So I want a pressure force in the C plane looking at what? Where does it go? Or how do I write it? So it's a sigma, right? It's in the Y plane or it's in the C plane? Yes. Y, Z. Why? Yes. So Chris, I'm looking for a surface force in the Y plane looking at C. Mm-hmm. Mm-hmm. Yeah. Mm-hmm. You just make sure that I'm not saying weird stuff. I don't have that in my notes. Oops. Can you guys check that really quick? I think it will be lecture 8. We should explain direction. It's like sigma, just like sigma I J. Let's see if I can look it over the clipboard here. Yeah, so it's on the lecture 8. So sigma ij, I plane on which stress acts. J is a direction. So yeah, it's like that. I plane J direction. Nice. Yeah, it was not confusing. Yeah, I don't know why I erased it. Yeah. I mean, the direction. So yeah, we were all right. Good. And basically, sigma, it's defined as all the pressures, which are this guy, you were saying, because they are acting on the plane that they are directing to, so they're squeezing for volume, which is a pressure times identity matrix plus the stresses, which are the ones that we're talking about. Like, for example, the one that you just said that is acting on the C plane, looking at Y, those uh, sigma in the vicinity of it. All right. So I think I'm going to write some vectors in the board, and I want you guys to tell me what they are, and after that, we can call it a day. All right? Awesome. So something that, so basically force, in this case, is defined as pressure and volume, at least for the pressures, right? So what should be volume? Should be area. Listen to it. Yeah, the for the normal forces, which are for pressures, is pressure times area, not times volume. So, for example, I'm gonna make this for myself, and then I'm gonna ask you guys to do other ones. But do I have that one? Okay. So for this vector is acting on the x plane, and it's a pressure. So its direction is also into x. So basically, its only component is going to be on the x. So y and c are going to be equal to 0. Right? For x, we're going to have p for the pressure restricted to x times the area. So the area in the plane x would be, it's a plane, will be delta c times delta y. Yeah, yeah, they're talking about like y is equal to 0, 3. Yeah, that's basically this, delta y. Exactly. So the area for this pressure will be, as we said, delta z times delta y. So delta c times delta y. 0, 0. So now I want you guys to figure it out, the pressure in the x plus delta x plane, pressure in the y plane, pressure in the y plus delta y plane. Pressure and the V and pressure on the C plus delta C. And very important to I want you to clean up there, but the gravity also. I've chalked for both of them. Just a bit. Oh yeah, not a fact. Why? Yeah. Yeah. Kristen, you want to come into the world? Yay. Thank you. Let's have this one for the other one. Right.
You can just move it on.
No, they are not. That's an illusion. Yeah.
Zero, zero, and whatever you want.
That wouldn't be wrong.
Okay.
Mm-hmm.
Yes, it is.
Really? For some reason, I really like it. It's, oh, really?
Mhm.
Thing with chalk is that during COVID, I watched a lot of lectures from MIT up on coursework,
Mhm.
and I feel like an MIT professor every time that I'm writing chalk. I don't know, something special about it.
I think I mean, a lot of the schools I went to were like still pretty recently. So like Transport or like
Not
the
a,
school, yeah, because the school was built so
yeah,
recently.
yeah. They were only,
Same thing with like if you're in, like newer US buildings, they don't have chalk.
yeah, they don't. They do not.
But but I like that you can have multicolored and English here. And
Pretty crazy that it's easier to ride with a thicker chalk than with this slimmer one.
yeah, but you don't right with it, but it's
That's right.
yeah, probably. I guess
But we're being considerate. Oh, this is lecture 5. No, you're good. You got, with me, you got the, no, that's not a vector.
Oh, is that one?
The gravity,
So gravity is only in the Y.
that's not included. Yeah.
I know it's minus two.
In that case,
Would it just be my feet, or would I need to? It was gonna be all 30 for that.
Yeah.
And,
will be city, the volume times the, what do you call that? Density times the
this is the,
magnitude of G. Yeah, that's all the. Mhm.
Yeah.
Any time.
okay. I can't remember.
You can erase it if you want.
But my life is mine.
That's a good question.
And then with
Row.
the
No, that's a row and a G.
yeah.
But since you're already writing it in vector form, there you're gonna write only the magnitude. And we set the magnitude as this.
Mm-hmm. It,
Yeah. And now